suspicious, or benign. And this takes a lot of training sets. Is it known that this registry is commonly changed when IE is visiting a web page, or this file is constantly changed? So in a high interaction honey client, it's constant. It's kind of a constant update, and also restarting the machine state is time consuming. So back to XMON. Where does it fit in? It's a hybrid model basically between low interaction and high interaction. We wanted some of both worlds. We wanted to increase the performance level, so we didn't want to be as slow as sandbox type routines, but we wanted the speed to be quite fast. We wanted accurate detection of both known and unknown exploits. Generally in the signature detection model, you're looking for known exploits. You're looking for known code that you've seen that's malicious. The behavior analysis system doesn't care what it's looking for as code. It's going to be looking for behavior that's generally not known to be benign. So with XMON, we were looking for known or unknown exploits. So it's a nice in-between. We wanted something that eliminated the need to monitor and restore the system state and reduce the uncertainty. We really wanted something that was more accurate, that could determine, is it malicious or is it not malicious? So now with XMON, we can launch multiple browsers. We can launch multiple browsers because we're not monitoring the state of the machine. We're monitoring the internals of one browser. We're monitoring basically where the redirection is happening. We visit, each one of those browsers, visit URLs, and we disallow any change to the state. And while we visit the URL, as I said before, we're looking for the redirection. And when we can see that it actually redirects to the heap or the stack, or there's some other different methods that we didn't mention or we're not going to mention, we're focused on the heap here, we can tell if it's malicious or benign. So, XMON was a system that we put in place that we needed because it's real-time interaction where we visit websites. We're not only looking for signatures. We don't need to download the machine, let things run on the machine. This takes time, up to sometimes 90 seconds to see what's going on, what did the exploit actually do, monitor the state, constantly restart the machine. This was a really nice in-between. So one thing to also note is that XMON is not something that we determined to be the solution to everything. It's one thing that fit in nicely at the top of our layer to kind of filter in how should we proceed, basically. Does it trigger to the heap? If not, then we'll throw it to all our other systems. And the call technique is basically something that, Matti and I, we were discussing when he was in Tel Aviv, I was in San Diego. I was like, this is kind of cool. Let's add this. Let's see how it works. We played for a couple months with it, played with lots and lots of exploits, and it kept on having 100% kind of, or close to that kind of rate. And we're like, well, let's make a tool and let's throw it into our systems. And it seemed to be quite successful. So we kind of wanted to share that research with you, to play with. One thing that we might be doing is, at least for the research community, at some point, having an open interface where you can go and enter in a URL and determine if it's malicious or not. Obviously, this always begs attackers to go and put that URL so that they can see if our systems work or not. But XMON is meant to be a tool that we're constantly kind of playing with, the new exploit techniques, and changing on a constant basis. So, is there any questions? I'm sorry, I can't hear you. You don't have to, but we chose to. We chose to, basically it was simple, 5 minutes to create a basic IDA plugin and go in and look at all the calls. Right, so when it's dynamically looking for DLLs? Right. All right. So what we've done is generally, we did a little bit of pre-research in that we took the entire system, scanned all the DLLs that were actually on that system, and generated the list for every single DLL. So that when that DLL actually loaded, we had that list ready to go. You have to run kind of that initialization. Is there any other questions?
You mentioned one potential pitfall would be changing the kind of jump and pointer call.
Yeah. It's not that we've seen this happen. It's that, we write a lot of exploits ourselves, and constantly we're just trying to see how can we get around our own systems. So we played around, and that's one way we would determine, well, when XMON's looking at the redirection, at one point does it say, okay, here's a call. If it goes right to the heap, that's malicious. If it goes call and then trampolines for a few instructions, that's malicious. But at what point does it actually stop? How many instructions do we actually monitor before it goes to the heap?
Would attackers using those techniques, would that potentially decrease the reliability of their exploits, or is it just simply make it, a few more instructions a little bit slower, not noticeable?
Yeah, I don't think it would.
It's not increase it.
Yeah, it wouldn't decrease it at all.
Can Microsoft do the same stuff
In the compiler? I was thinking, obviously we were thinking of these in terms of research tools. I know that, our company would always go, it's great if we could throw this into a product of some sort. Maybe. I think it's possible if for example, we're looking at, it's possible. But I definitely see this more as a research tool than something that would actually fit into a compiler or the OS. All right, if there's any more questions, find me after the talk, or else thank you very much.